We would like to describe what we mean by finitely generated abelian group. So let A be an abelian group. And x1 up to xn are elements of A. We will say that x1 up to xn generate A if for every x in A, there exist integer numbers m1 up to mn, sorry about this, mn, such that x is n1 times x1 plus, I'm sorry, m1 times x1 plus all the way to mn times xn. So let's give some examples. So let's start with z. Z is generated by 1. Okay, so what we mean by this is that every element in Z is either a sum of ones or a sum of its opposites, or the neutral element, which, so if you take a k greater than 0, then obviously k is 1 plus 1 plus 1. Here it almost seems like a tautology because we can think of this as k times 1. That's what it is. To make it a little more interesting, if we take z squared, then z squared is generated by 1, 0 and 0, 1. So if a finite number of elements of A generate A, then A is called finitely generated. So sometimes in these cases, it's a good idea to ask, okay, so can we think of a simple group? When I say simple, actually, we should not use the word simple with groups because somebody could possibly get confused here. But in any case, what I mean by that is, can we think of a group that we encounter very often, which is not finitely generated? And the simplest group we can think of here would be Q. So Q is an abelian group, but certainly it cannot be generated by finitely many of its elements. Let's try to think why. If you took, let's say, x1 up to xn, then and you took all the integral combinations, this is what we call sometimes this element, then the integral combinations of a finite amount of rational numbers cannot have arbitrarily large denominators. So if, let's say, the largest denominator that you encounter in these elements is, I don't know, 1,000,000, then when we add up these elements, we can never have a denominator that exceeds the least common multiple of the denominator. So I guess saying that the largest is 1,000,000 is not that helpful in figuring out what the size on the sum would be. But, you know, the bottom line is that the least common multiple of the denominators of these elements will be pretty much the largest denominator that we're going to encounter. And certainly that cannot be all of Q. So Q is not a finitely generated group. And we will see that in our project, we will deal mainly with finitely generated groups. Thanks for watching.